Okay, let's welcome Siegfried.
So I know it's on a very short notice, and yes, I did not prepare my talk because it was no intention to give it today, but as it happens, yes. So Santo's flight is actually cancelled, and I have, let's say, the Ehre, the honor to give a backup talk. So it's about evil performance testing. Anyone doing performance testing as a hobby or as a professional thing? Oh, I see hardly any hand here. There should be many more hands in my opinion. Yes, I saw your hand, no worry. And another one. Okay, so a few words about myself. My name is Siegfried Göschl. I'm a backend engineer. Nowadays, I'm a thing called solution architect. It's less about programming Markdown and Confluence and not Java code. And I'm infamous for my, oh damn it, motivational skills and management presentations. So stay tuned. What I do is I help at the Java meetup, and I'm also co-organizer or part of the organizer team of the DevFest. That's actually the reason why you're seeing me here. So what is even better than performance testing? It's actually performance testing with Dilbert in the Dilbert universe. So do you know the Pointy Haired Boss from the Dilbert universe? So it's sort of comic, cartoon, whatever, 30 years ago. And one protagonist is the Pointy Haired Boss, and he says, remember, quality is our top priority. I mean, how often have you heard that in your career? I guess quite often. And yes, and Pointy Haired Boss is actually the boss of a company named Path E-Tech Management. It's quite a fancy name because it's a merger. I mean, it's a fictional company, you're well aware of that. But it's a merger of Pathway Electronics and E-Tech Management. And the name is a little bit unfortunate in that sense that if you mispronounce it, it sounds like pathetic management. I don't know why. So this fictional company is located in North America, and they made mega bucks with a product called GRUNTMASTER 6000. So that's the outset. And now, you remember, quality is our top priority. They're going to launch GRUNTMASTER 7000. It's a brand new product, and it shall make additional megabucks. And let's assume you're a potential customer for GRUNTMASTER 7000. You think, shall I buy it? It's a big investment. You have really hard performance requirements. Any performance problem costs you megabucks on your own. So you think, I'm a smart manager, you know. I say, yes, I would like to purchase those brand new GRUNTMASTER 7000, but I need a mandatory performance test because I want to be sure that everything works without any problems. I mean, think about it. It's a good idea, isn't it? Okay, let's have a look at it. So you're a very smart manager. You're also saying it's not only performance test, but I would like to have performance test success criteria. I mean, that's quite a mouthful, but it's important. You say, well, if you run a performance test for this fictional component, I would like to see 0 errors. I would like to have a 99th percentile of less than 50 milliseconds. And I would like to have a throughput of more than 50 requests a second. Sounds reasonable for my customer base. And yes, Path E-Tech Management is doing the performance tests. Everything is happy. They're sending over their report, and you're reviewing it. So you're looking at the pathetic management test reports, and it looks awesome. So basically, they executed the performance test. They had those 48,000 requests. If you look at it closely, there are no errors. Average response time is something like less than 50 milliseconds. Everything is fine. You look quickly at the graph saying, well, hits per second. yes, okay, there's a little bit of ramp up, something happening in between, and then basically a tear down of the G-meter test suite, whatever. Looks good to you. You're happy. But you're smart. You're also looking at the percentile, 99% percentile. And yes, it's also good. I mean, could be hardly any better. So at the end of the day, you're just reviewing your performance test acceptance criteria and say, yes, I wanted to have 0 errors. And I got 0 errors. Check. I requested a response time of the 99 percentile less than 50 milliseconds, and I got 18 milliseconds. Check. I requested a throughput more than 50 requests a second, and I got 80 requests a second. Check. So you decide, yes, we're going to purchase that. You deploy GRUNTMASTER 7000. And strangely enough, you have slightly mixed end-user feedback. Something like, brace yourself, GRUNTMASTER 7000 is coming. Or in social media, you see something like this. Or another meme popping up. So, yes, you're a little bit, let's say, unsure because, I mean, you did everything possible. You did a performance test, but your customers are unhappy due to performance reason, and actually you don't think there is any good reason for that. But again, you are a smart and successful manager, so you decided to run your own performance tests because something is obviously wrong. And yes, you write your own performance test, and let's put it that way. The results look slightly different. So you still don't have any errors, but the average response time, if you look at a total average response time, is well above 1 second. And that's strange because it's your performance test. You're basically running basically the same performance test requirements, but you get completely different results. And you look at a graph from G-meter, so looking at the hits per second, and you see it's very strange. You have to ramp up. It's odd because you actually would like to have some sort of flat line, some consistent throughput across the whole performance test run. And if you look at the percentile again, you see something very strange. So the green one on the top is the 99% percentile, and it's sort of stuck with 10 seconds. And yes, you're puzzled. How come? Are you also puzzled? Okay, that's good. So let's look at the performance test result of performance tests you implemented, you ran, you examined, and found out they look completely different. So again, we have 0 errors, that's fine. So that is basically reproducible. But if you look at the response time at the 99% percentile, you see before that, from the pathetic management test, it was below 50 milliseconds, and you are measuring approximately 9,000 milliseconds. And the throughput is actually well below 50 requests a second. You're hitting 40 requests a second. So again, strange. And now comes the interesting part of the presentation, because that was just a warm-up, yeah, to make you a little bit interested. So if we look at those performance test reports of the same system, which look completely different, what is right and what is wrong here? Okay, let's have a deep dive on that. So the big question is, was pathetic management lying about the performance tests? I mean, could be. But their answer is, one does not simply lie to a customer. Reason for that? For that you have marketing. Sorry. So let's have a look what actually causing the difference in these performance test reports. So for the records, this is Dilbert, yeah. So this is a nerd. He works in the software industry. He has 2 pens in there and a tie. And many moons ago, actually went to Carnival in a Dilbert costume. But no one recognized it, unfortunately. Anyhow, so one problem we're experiencing now is a thing called coordinated omission. Have you ever heard about coordinated omission? No? Anyone? Anyone doing performance tests and haven't heard about coordinated omission? The good thing is you are in the right presentation now. So what is coordinated omission? So what's really happening is, if you look at the response time diagram here, my fictional GRUNTMASTER 7000 stalls after 50 seconds. It actually stalls for altogether 10 seconds. So think of it like a garbage collector. We had this today that I'm working as a garbage collector, and I said something like, stop the world garbage collection. So what you're seeing here is actually a more extreme version of stop the world garbage collection. It's running nicely for 50 seconds, but then the application stalls for 10 seconds. And if you're running now gmeter, you actually have a fixed pool of worker threads. Anyone using gmeter before? Yes, a few hands. So think of a performance test tool. You would like to execute tons of requests, and in order to do that, you actually utilize a pre-configured, instantiated thread pool. Let's say, containing of 10, 20 worker threads whatsoever. And the funny thing is, when you're here in those 50 seconds area, the gmeter tests are happy because the worker threads are sending requests, the worker threads are getting responses, everything is fine. You get excellent response time. But what's happening here in those 10 seconds? And that's the funny thing. Those gmeter worker threads, they send a request, and then they have to wait for 10 seconds. I send a request to a system which stalls for 10 seconds, so I'm not getting any response back. Everyone would say that's obvious, isn't it? And if you think about it, we omitted tons of other requests because my worker threads were stalled as well, together with the server application, because they were waiting for the first response. That took 10 seconds, so we omitted tons of requests. And that's the reason why this problem is called coordinated omission. And I'm quoting actually the inventor of this term. And how to pronounce his name? Gil Tenne. Okay. So he says coordinated omission is a term to describe the phenomenon where the measuring system inadvertently coordinates with the system being measured. So that's actually happening behind the scenes. Your server application stalls, and inadvertently, your gmeter worker threads, your performance test also stalls because you're using a fixed-sized thread pool behind. And that's the reason why those term coordinated omission was invented. And I'm showing here Gil's original example. He was doing it, let's say, in a more extreme way with 10,000 requests happening, response time 1 millisecond, and one request taking 100 seconds. And if you look at it, then you say, well, looking at the numbers, if you just look at average, the average response time is 10.9 milliseconds. The standard deviation is also fine. And the 99 percentile, whatever, with the 4 nines, is also 1 millisecond. So if you look just at standard metrics for performance testing, you might miss such a stalling system. And that's the reason for this coordinated omission. The next culprit are actually percentile charts. So any one of you looking at percentile charts regularly, let's say Grafana dashboards, things like this? Yeah, we all do. But on the one hand, they are quite nice. So they are used for performance testing and monitoring. And they actually contain a lot more value and information than just an average value. But if you think about it, percentiles are effectively removing information. So if I look, and that should be actually the thing you take away from this presentation. If someone says, I measured the 99 percentile and my response time is below 50 milliseconds, you should not be impressed. You should be asking, by the way, what happened to the remaining percent? Because this is not answered, yeah? This is basically removed. That part of the information is actually removed. So if you think about it, percentiles are just removing outliers. And if you're coming from a statistical background, that might make sense because you have diluted test data, you're cleaning that up, you say, that's an outlier, I'm going to remove it because it doesn't make any sense, it's not possible, whatever. So this is fine. But for performance testing, you actually remove the most valuable information. So let's have another look at percentiles. So if you remember math, there is something like median value, like average value. And if you look at normal response time of a systems, it's a curve like this. It's going up, and then you have a thing called the long tail. And the outliers are here. So if you look at the percentiles, those outliers are removed. And that's actually the problem, because you do not see an obvious performance problem. So stats look nice, performance test report looks nice. And the good thing is, you're not alone with the problem. So this is, do not remember, this is some example I found online from a well-known company. Sorry. And they're saying, well, they improved their product, it's now much faster, and they actually published the graphs to show the result. And then you say, range query, it's a 50% percentile, or range query, 99% of the percentile. And as I said, the real thing you should take out of this presentation is always asking, what happened to the remaining 1%? Because according to GIL 10, that's actually the value you're having, yeah? Everything else is noise. And I'm lucky because I did remember this quote. So his original quote is, the number one indicator you should never get rid of is the maximum value. That's not the noise, it's the signal. The rest is the noise. So if this is the only thing you take out of this presentation, I'm a happy man. Another thing we should look at, have you ever came across workload models in performance testing? Because that actually is the core of the problem. So in my test scenario, I used a closed workload model, which has a fixed number of virtual users. It's actually this thread pool you're instantiating has n number of worker threads, and you're using that. And basically, if they got stuck, that's fine, because they are just a thread pool, they do whatever they can. And yeah, and you're basically implementing such like a queuing system, like a call center. So if your call center agent finish a call, then the next customer actually get routed to the call center agent, accepting the call. And have you ever called, let's say, Wiener Netze or Sozialversicherung? That's the difference, yeah? So you wait 2 hours to get basically a quick response that they are not responsible for that. That's a closed workload model. So what do you do in a closed workload model? Yeah, again, it's just funny, but so what with a closed workload model, you're mostly measuring response time. You're not measuring the wait time. And the open workload model is completely different. You basically have an ever-increasing number of concurrent users if the system you're testing actually stalls. Because in reality, it's like in the real world, when you have a portal, whatever, those new users are arriving anyway, yeah? Regardless what the existing users are doing. If your existing users are stalled, waiting for something, those new users coming in, and they are also waiting. So my good example for that is, do you have daughters? Come on. Thank you very much. So just try to buy a Taylor Swift concert. Impossible. Sorry, not the concert, but the ticket for the concert for your daughters, yeah? Just try to do it and you find out, yeah, you don't get through because there are millions of people already in the queue after 10 minutes. So, yes. So what we're measuring here is something different. In the closed workload model, we were measuring response time. And in the open workload model, we are measuring service time. And there's a nice example for that. So you remember that from noon when you were queuing for the pizza slices. So you have this lucky guy in front just taking the last slice. Okay, well, we had hopefully more than enough slices. But you at the back, you actually have to wait because you have to wait through the whole queue. Then you are at the counter and then you actually ask the guy politely, could you hand me a slice of pizza? And that one is response time and that one is service time. So that's a big difference. So when you do performance testing, keep in mind what you are going to measure because that depends actually on your application or on your test scenario. So let's have a quick look. Common testing tools. GMeter actually supports closed workload model and for some time now an open workload model. Gatling is mostly the other way around. Gatling started with an open workload model and now supports for some time a closed model. And SoapUI, in my opinion, is broken. You should never use it for performance testing. But it uses a closed workload model, if you're interested in. So, and now comes the question. Was Pathetic Management doing evil performance testing? Were they lying to you? Yes or no? What do you think? Okay, I see shaking hands now. Yeah, because actually they were not lying in that sense. Because the funny thing is, the thing I showed you before is actually a real GMeter test report. It's not a fictional one. It's just something from my application I tweaked actually to implement those stalls after 50 seconds. And it's something you can reproduce, yeah? Actually, the GMeter test suite and those little servers actually on GitHub, so you can start it, you can rerun the test. But the main point is that this Pathetic Management, the good GMeter test report, was actually using a closed workload model. And you, in your tests, you are using an open workload model. And this tiny little difference in the configuration and setup actually makes a huge difference. So again, thing is, when you do performance testing, think what workload model you need. Is it open or is it closed? Because that's a really fundamental question. And you should have an answer for that. So, and to make the story, let's say, to finish the story, is the closed workload model used in the good GMeter test report is actually affected by the coordinated omission. Because my GMeter worker threads, my fixed number of worker threads were actually tied up, couldn't send any requests, and that's the reason why you have very few requests taking 10 seconds. And then you come to your percentiles, and those 99 percentile actually cuts away those 10-second response time. Because from the test report view, it's an outlier. It needs to be removed. And that's the reason why you do not see those 10-second stalls. I mean, actually, it's a thing of beauty if you think about it, yeah? I mean, you did everything right. You set up a performance test, you configured it correctly, you used a standard out-of-the-box closed worker thread model, because that is what GMeter provides most of the time, or is being used most of the time. And then you look at the reports, and they're just misleading. And again, you did everything correctly in a sense, yeah? So no evil performance testing in that sense. So, so the message for you is performance test reports can be misleading. So you should really check. And one of those things I mentioned before is you should check the maximum response time. Because the maximum response time is the real value of the performance test. And if you use percentiles, you're actually consider long runners as outliers to be removed from the chart. And depending where you're sitting on the management desk, that might be desired or that might be a lie. So it's basically up to you to decide. And coordinated omission is actually everywhere. Yeah. So I'm quite sure you implemented over your career some sort of performance monitoring in your application server, where you just measure the response time and not the service time. So I'm quite sure every one of us did it before. Again, it's perfectly fine as long as you know what you're doing. And ensure that your workload model basically reflects your expectations. And last famous one, use your brain when doing performance testing. Question and answers. So I hope you enjoyed the presentation. It was like a stand-up comedian now for me. Yeah, no time for preparing.